Hello, and we're back. We're continuing talking about the parent functions of the functions that we're going to see in this chapter. We also need to talk about the parent functions that are not polynomials. So the first thing I want to look at is the parent function for a radical. And really it's the major one we want to look at here. So the radical is y equals the square root of x, or at least the first even radical is y equals the square root of x. If I was to graph y equals the square root of x, here's what it would look like. It's kind of a parabola on its side, but it's only the upper half. So I would start here and go up that way, and we would keep going that way. And it keeps going up as we go to the right. And one way that you can see this is because whatever's underneath the radical, called the radicand, must be greater than or equal to 0. That's how you find the domain of this type of function. So in this case, that means that x must be greater than or equal to 0. So I would start at 0 and go to the right. Also, because there's an understood positive out here, that means that it's only everything above the x-axis. Now let's look at the x and xy coordinate table. Now, on this one, I don't want to put 0 down here because that's where we have to start. 0 should start at x. And if you take the square root of 0, you get, well, 0. The next x I want to use is 1. And the next x I want to use, well, let's talk about what's the square root of 1? 1. The next x I want to talk about is not 2, and that's probably your first instinct. The reason I don't want to do 2 is because if I type in the square root of 2, well, I get the square root of 2. Or you would probably get somewhere around 1.4 something. I think it's 1.47 or something. But if I have a 2 right here, that doesn't really do me much good because I don't know exactly where it is on the coordinate grid, once I get a coordinate grid here. So what I'm going to do is instead of using 2, I'm going to use 4. And the reason why is because if you plug in 4, the square root of 4 is 2. In other words, I want to increase my y values by 1 each time. So the next one would be 3 here, but in order to get a 3 from this, the next x that I could use would be 9. And I would probably stop here. But if you want to keep going, I could go on to 4, but to get a 4, the square root of something equaling 4 means that x is 16. So that's how you can find your parent table. Another radical you want to look at is y equals the cube root of x. Cube root is much like the square root, except the domain is all real numbers because you can take the cube root of a negative number and give you a positive value. So if I was to graph on some coordinate grid, I would get something that looks like this. It's kind of the cube function, but it's on its side. So for my table, I am going to need to have the 0 in the middle because I need stuff to both the left and the right of 0. So I'm going to put 0 in the middle here, and again the cube root of 0 is 0. But I need stuff to the left and to the right. So I'm going to use the negative 1, which gives me negative 1, because the cube root of negative 1 is negative 1. I'm also going to use negative 8, because the cube root of negative 8 is negative 2. Notice I'm just going down by 1. And the same thing up here. If I want to go up by 1, well, to get a 1 from this, I need the x value to be a 1. And in order to go to a 2 here, the cube root of something equaling 2 means that that something has to be 8, because the cube root of 8 is 2. And this is the parent function you would want to use for a cube root of x. There is also rational functions, but rational functions are a little bit odd. So I'm just going to really leave those and deal with them only in chapter 3 at the end of the chapter.